The proliferation of uncrewed aerial systems, UAS, in recent years has revolutionized various industries, from agriculture to logistics. However, this technological advancement has also introduced significant security challenges. The urgent need for effective counter-drone solutions has become increasingly apparent as malicious actors exploit these devices for nefarious purposes. The drone threat landscape is rapidly evolving, with incidents ranging from airport disruptions to potential attacks on critical infrastructure. In the United States alone, thousands of drone incursions occur annually along the southern border with Mexico, highlighting the scale of the problem. These agile, often commercially available, devices pose complex security risks due to their accessibility, payload capacity, and potential to fly long distances. YWA_market_voice_newsletter_June. Spotify. Listen up. Get timely threat insights and practical solutions from the leading publication for security pros, Security Management. Follow. Traditional counter-UAS approaches, limitations, and risks. Conventional counter-drone technologies, derived from traditional military air defense settings, while valuable in certain scenarios, often fall short in addressing the nuanced challenges posed by modern UAS threats. Radar-based detection systems, for instance, can generate false positives from birds or other flying objects. Optical camera solutions struggle in environments with limited visibility or complex urban landscapes. Acoustic detection becomes less effective as drones become increasingly quiet, especially in noisy environments. More concerning are the limitations of traditional mitigation techniques. Kinetic solutions, such as net guns or the shooting of many different kinds of projectiles, carry significant risks of collateral damage, especially in crowded areas. Jamming and electronic warfare methods, while temporarily effective, can disrupt essential communications and operations in the surrounding area. These shortcomings have spurred the development of more sophisticated, no or low collateral damage solutions that can effectively neutralize drone threats without compromising safety or continuity of operations. SMLO Rec 1, Security Management House AD. Instagram, RF Cyber, a next-generation approach to counter-UAS. Among the emerging technologies in the counter-drone space, radio frequency, RF, cyber stands out as a promising solution that addresses many of the limitations of traditional approaches. RF cyber takeover technology-based systems detect, locate, and identify rogue drones in the airspace. They then neutralize threats by taking control over the drones and landing them safely in a predefined zone. During the mitigation takeover process, the rogue pilot loses all control of the drone and cannot regain it. The system passively and continuously scans and detects unique communication protocols and characteristics used by commercial drones. Once detected, the system locates and tracks the drone's position with high accuracy. This includes a takeoff position near the pilot. Authorized drones can continue to function without interruption, while the system tracks the rogue drone and associated remote controller position. This technology empowers military, security, and law enforcement organizations with operational flexibility across domains, environments, and scenarios. Since the system does not rely upon jammers or kinetic technology, it avoids collateral damage, interference, disruption, or disturbance. The system takes control over the rogue drone without interfering with other drones and communication signals. Continuity prevails as communications, commerce, transportation, and everyday life can proceed smoothly. YWA_market_voice_newsletter_June. YouTube. Oh, it's on! Be the first to watch the latest news and updates from Security Management and ASIS International. Subscribe. Key advantages of RF Cyber counter-UAS systems include precise detection and identification. RF cyber systems continuously scan for unique characteristics of commercial drones, allowing for accurate detection without false positives. Takeover capability. Unlike jamming methods, RF cyber technology can take control over a drone, enabling the CUAS operator to fend off or safely land the target drone. Safe mitigation. By taking control of rogue drones, security personnel can safely guide them on a safe route to predetermined secured landing zones, minimizing risks to bystanders and property. Distinction between authorized and unauthorized drones. Advanced RF cyber systems can differentiate between friendly and hostile drones, ensuring that legitimate drone operations remain unaffected. Operational flexibility. These systems can be deployed in various configurations, including stationary, vehicular, and man-portable options, adapting to diverse operational requirements. The RF cyber advantage in sensitive environments. One of the most significant benefits of RF cyber technology is its ability to operate effectively in sensitive civilian environments. Unlike traditional counter-UAS methods, RF cyber solutions avoid collateral damage and maintain continuity of operations in critical areas, such as airports, stadiums, and urban centers. This technology has already been adopted by government security agencies, military units, and law enforcement organizations worldwide. Its proven effectiveness in protecting high-profile events, VIPs, and critical infrastructure underscores its potential as a cornerstone of modern airspace security. Comprehensive drone incident management. RF cyber systems offer a holistic approach to managing rogue drone incidents throughout their life cycle. The process typically involves detection and alert, rapid identification of unauthorized drones entering protected airspace, tracking and localization, continuous monitoring of the drone's position, including its takeoff location and the pilot's position, threat assessment, analysis of the drone's characteristics and behavior to evaluate the level of threat, mitigation, either fending off the drone by making it return to its home position, requiring it to hover in place, or taking full control to land it safely. This comprehensive approach ensures that security personnel have complete situational awareness and control throughout a drone incursion event. SMLO Rec 1, Security Management House AD, YT, integration and future-proofing. As the drone threat landscape continues to evolve, counter-UAS solutions must adapt accordingly. RF cyber systems are designed with open architectures, allowing for integration with existing command and control systems and complementary detect and defense technologies. This flexibility enables the creation of multi-layered defense strategies that can address a wide range of drone threats.